Titrations can be fun. This is what scientists use to determine the concentration of either the acid or the base that you're given. Okay, you can combine an acid and a base, and again, knowing that there's going to be this neutralization reaction, you're able to determine mathematically either how much or volume you would need to neutralize a specific acid or a base. So in this example, most of the time, the Erlenmeyer flask, which you can't see but you can see in your notes, is going to have the acid. Okay, and in that flask, which looks like this, it's going to have an acid and some type of indicator. So what happens is, inside this thing called a burette, we have the base. And what you do is you measure where it starts and where it ends. And you measure this by that little line down there is called the meniscus. And in this case, it's going to be roughly about 39.12. 1, 2, 3. So we have to measure down. See how these are different? You would expect them to be the higher number on top. But what's going to happen is we're starting at a high level, and we're going to open this little thing, this little stopcock, and out is going to come this base. So we're starting basically just kind of inverting it and looking at what it's going to be. So when you do titrations, you would basically just put the base inside the burette, B for B, acid and indicator in the Erlenmeyer flask, measure beginning volume and your ending volume. So we use reference T, table T, for the molarity of an acid times the molarity, or excuse me, times the volume of the acid equaling the molarity of the base times the volume of the base. So Ma is going to be the molarity of the H ions. And in the case of the molarity of the base, we're looking at the molarity or concentration of OH ions. Volume of the acid, volume of the base. So let's try the first example mathematically together. So molarity, volume. This is going to be my acid. I know because I can look at table K. And I have 25 milliliters. Okay, and it is neutralized by, there's the volume, and there's the concentration. Let me just do this in a different color. This is the volume, and this is the concentration of the base. So 32.1 milliliters. Make sure that your units on the left are the same as the units on your right. 0.150 molarity. We have an unknown, okay, our unknown molarity. So we do the math, and as we do the math, it's going to be, this is going to equal 4.815. We don't want to round until the very end. We're going to divide this by 25, divide this by 25. Solving for x is going to equal, so 4.815 divided by 25 gives us 0.193 molarity of the acid. Okay, same example here. Okay, how many milliliters of, this is a base, and they're asking for how many milliliters, so let's just put that in there now. 0.2 molarity times an unknown volume for the base is used to neutralize 100 milliliters of a 0.1 molarity solution of an acid. So we do that. This is roughly about 10. Okay, we're going to divide this by 0.2. So X is going to equal, X is going to equal about 50. And again, if you're not sure what the units are, look back to the question. This is in milliliters. Now, in the case of other types of titrations, this is kind of adding into the fact that you might have to balance the equation. So when we look at example 3, you might be given a question like, okay, well this is an acid, this is a base, and again, I know that by looking at table K and L. What is it going to make? We know that it's going to make water, okay, and it's going to make some type of salt. So this is already taken, and what's left is the K and the Cl. Let's look at it across, okay, looks pretty balanced to me. Okay, so once we complete the equation, the neutralization reaction equation, we can compare the number of moles of hydrogen to the number of moles of the hydroxide. And we did say that it has to be equal. So look back at your notes. Okay, equal mole amounts in order for that neutralization to truly occur. Determine the concentration of that. So let's take a look. We have to go back to the reading. Okay, this is talking about the acid. This is talking about the base. Let me just use an arbitrary color. 0.15 molarity times 20 milliliters is going to equal an unknown molarity of the base times 18 milliliters. So we do that, that's roughly 3. Divide that by 18. So NB is going to equal 3 divided by 18, which is roughly 0.17 molarity of the base. Try example 4. If you need any help, let me know.